morning, students. Today I am going to explain you the assembly language programming of 8085 microprocessor. Now in this regard, I discuss one sample problem programming. The question is, write a assembly language programming program for 8085 microprocessor to find the largest number assuming the numbers are stored in memory location 900H and 9001H and store the result in memory location 9005H. So this assembly language program is for 8085 microprocessor. Now here, how to write the program? First of all, the programs are written in the sequence of instruction, and that instructions are counted by program counter. So the program counter count the address of the memory location, and then the instructions are written in sequence instructions. Now here, first of all, the number is stored in the memory location 900H. So first of all, we should get the first number. How to get the first number? Now for that, we use an instruction LXI H, 900H. That means the address of the memory location is 900H, and we are storing the address, always we are storing the address in HL pair. So LXI H, 900H is our first instruction. Then the second instruction is, this is the first number we get. First number, we are getting the first number. Then we move the number to the accumulator. Move A, M. The number, first number is now moved from move to accumulator. By means of this instruction. Then we get the second number. So for that, we should increment, that is the instruction INX H. That means increment the HL pair. That means we are getting the second number. We get the second number because the second number is stored in 9001H. So if we increment, the next number is come. Now next, this first number and second number we compare. So for that we are using a logical instruction CMP, compare. That is a logical instruction, compare M. That means we compare the memory content with the accumulator. That is a comparison. We compare the second number with the first number. Now here the comparison is nothing but a subtraction between the two numbers in 2's complement method. In the 2's complement method, if the one number is subtracted from the other number, minuend and subtrahend, then there is a carry. Because in 2's complement method, we are using the subtraction is done by means of addition, and if there is a carry, then the first number is minuend is greater, and if there is no carry, then subtrahend is greater. So in this case, when the comparison starts, then we use one conditional instruction, JNC, jump if no carry, JNC, and here we are using a label that is suppose ahead. Ahead is a brand name, it is a label. This is a conditional instruction. If the condition is not satisfied, then it go to the label ahead, this label ahead. Otherwise, the next instruction is carry out. That means move a comma n. Then if this number is this instruction is not satisfied, then this instruction is executed. If it is satisfied, then it jump to the label ahead, and here we store the greater number, that is the 9005 STA 9005H. That is the address of the memory location where the larger number is stored. Then the program ends and this is halt. Now the next step is how to write the memory program counter content. That means the address of the instruction to be executed. In this program, you see there are 1, 2, 3, 4, 5, 6, 7, 8 instructions. So this simple program consists 8 instructions, and the program counter count one by one instruction. Now here you see LXI H, suppose if the program counter is initialized first 200H, that means H stands for hexadecimal number. These are in hexadecimal. So if the first program counter content is 200H, then the next instruction number is 2003H. Why? Because this instruction is a triple byte instruction. Triple byte instruction. Triple byte instruction means any instruction consists address, that is a triple byte instruction. Any instruction consists 8-bit data, that is a double byte instruction, and any instruction which does not consist any data and address, that is a single bit instruction. So this is a triple, since it is a triple byte instruction, so the program counter content next instruction number is 2003. Then this is a single byte instruction because there is no data, 8-bit data and no address. So the next sequence of the program counter is 2004H. Then this is a single byte instruction because there is no data and no address. Then the next sequence of the program counter is 2005H. Now here compare M. This is also a single byte instruction. There is not, since there is no data or no address, so the next content is 2006H. Now here JNC ahead. This instruction, this is the program counter content of the first instruction, second instruction, third instruction, fourth instruction and fifth instruction. Now here there is an address. So this is a triple byte instruction. So the next sequence of the program counter is 2009 for this instruction. And this STA2005, this is a single byte instruction. So this is equal to 20A. Why A? Because the numbers, this address is given in hexadecimal number. After 9 there is A. Then this is a triple byte instruction because this is a 16-bit address. So the next content is A, B, C, D. 200 A, B, C, D. 200 D. This is halt. Now this is the content of the program counter, and program counter one by one count the instruction. When the content is 200H, then this instruction is executed. After that this instruction is executed. After that this instruction is executed. These are the sequence of instruction to be executed. At last the greater number is stored in the memory content 9005H. And here you see this is a conditional instruction JNC. This condition is jump if no carry. If there is no carry, then the greater number is stored in the memory and that is stored moved to the accumulator. And if there is a carry, then the condition is not satisfied, then the next instruction, next instruction to be executed is this STA 9005. That means 9005 the accumulator content number is greater and that is stored in the memory location. So in this way, sequence by sequence, counting the from as far as the content of the program counter, the sequence is maintained and the program indicate the largest number which is stored in the memory location 9005H. Now here you see how the JNC compare instruction CMP compare M. Compare M, suppose for example we say 900H, for example it is the number stored in this register is suppose 98H, and suppose in 9001H the number stored is 87H. So this number 98H, if it compare 98, it's a binary equivalent is 1001. This number 900, it's a binary equivalent 900H. Its binary equivalent is 1001 then 81000, and the 9001H is 9001H. Its content is now 87. 87 means 1000. It's a binary equivalent, and 7 is 0111. Now when it compare, then you see this is your mind. This number is mind. It is a subtraction mind, and this is the subtract. In comparison operation, what happened? This subtrahend is subtracted from the mind, and subtraction is done by means of 2's complement. The 1's complement of this number is equal to say 1000, and this number, its 1's complement is 0111. Now if we add this with 1, the 2's complement is found, and that is equal to 1. Now if you add this number, you see 01 is 1, 00 is 0, 00 is 0, 110 carry 1, 1101 carry 1, then 10110 carry 1, then 1010 carry 1, 1010 carry 1. And here you see there is carry. And if there is carry, then the next instruction is executed. So here you see there is a carry in the addition, 2's complement addition, the mind is added with the subtrahend. And if there is a carry, then the condition JNC, jump if no carry. That means if carry occur, then the condition is not satisfied. If the carry does not occur, then the condition is satisfied. If the condition is satisfied, then move to the level ahead. If the condition is not satisfied, then immediate next instruction, that is move A, N, is executed. And like this, the number stored in the memory location. So this is a simple program for 8085 microprocessor to determine the largest number by using the compare statement, compare instruction, logical instruction, compare, and the program, it consists 1, 2, 3, 4, 5, 6, 7, 8 instructions.